You got the little things to remember and all that stuff. You can read through that, but this data set is pretty lengthy. So obviously, data entry is one of the less enjoyable parts of data analysis. So you just got to kind of grin and bear it. But once the data is in your calculator, you want to use all the available resources of that calculator to save yourself from having to do any kind of additional work, unnecessary additional work. All right. So I'll show you a few different approaches. One way would be on the TI. So let me bring that up. So I already typed the data in, just because. So one thing that you could do is just go right to the histogram. All right. So that's second, y equals, brings up the stat plot. Option 1, turn it on, grab the one that looks like a histogram. I put all my information into L1, so L1 should be my X list, with frequency being 1. Each element in my X list occurred one time. All right. So then from there, I would hit zoom 9, so zoom stat. You could just hit zoom followed by the number 9, or scroll down like I'm doing and hit enter. And it'll bring up a histogram, but it won't have any labels, so we have to take care of that part of it. All right. The thing is, the calculator doesn't understand context, so we have to provide context. If I hit trace, it'll tell me the minimum and maximum for each bin. All right, each bar, the width of a bar, they call it a bin or a bucket. I don't know why they call it a bucket. That sounds stupid, but that's what some people call it. All right, but the bin width, actually bin isn't much better, but it's really an interval from 42 to something less than 46 and 2/3. And there's 4 entries in that list. That sounds wonderful. Except it's not. It's not wonderful. 42 to 46 and 2/3, I don't like the width of that interval. And besides, what are we going to get from this? All right, because the context here is 45 presidents and their ages. So, I mean, is 46 and 2/3 a natural cutoff for age? Probably not. We tend to think in terms of decades. All right, there's odd, weird benchmarks like 16, 18, 21, 25, 30, 40, 50, 55, 62. So you got your learner's permit, you got age to vote, age to drink alcohol, or other things that require you to be a 21-year-old. 25 is the age in which you can legally rent a car. All right, that's a fun one. All right, 30 is just 30. Nobody wants to turn 30. 40, that's a worse 30. All right, same thing with 50. All right, 55 is one retirement age, 62 is another retirement age, and so on. So like natural benchmarks. So if you wanted to make intervals based off of those numbers, that's fine. They have the democratic. Oh, that's fun. I merged democratic and demographic and made a new word that has no meaning. Demographic. So the 18 to 34 age group, and 35 to 49 age group, and so on. But in an academic sense, I'm thinking more like, let's just go by tens. All right. So the question would become, how do we manipulate this so that it goes by tens? You go into Window, set your X min and X max to whatever makes sense based off the context of the situation. All right. We're talking about the ages of presidents. So the lowest one was 42, so we want to go less than the 42. All right, the highest one was 70 something, so we want to go higher than the 70 something. All right, so we can say 40 to 80, just to be safe. If you really want to be safe, 30 to 80. The X scale is really where the magic happens. All right, you see that 4 and 2/3? That's in the TI, that's the bin width. All right, the X scale. We want it to go by tens. All right, so I look at my graph now. So I just hit graph after I make those changes, and it's truncated. The head got chopped off. All right, it's not tall enough. But I didn't know that going in, but now I do. So let me go back here and make it taller. All right, so I'll make this like 20 and see how it goes. Still not tall enough. So now I'll really play it safe. There's 45 values in a data set. I'm going to put 50 here. There's no way it's going to be too short now. So we're good to go there. But now I look at this and I see, that doesn't really look like much of a bar. So maybe I can bring this down to like 35. All right. So nice looking graph, would need to get that on paper. All right. But the first thing that we want to do is indicate what our classes, there's another name for bins, class, intervals, bins, buckets, they all mean the same thing. All right. So I'd go to trace. I'd want to get all this down. That 30 to 40 interval doesn't have any value, so we can disregard that. All right. Hit the right arrow. 40 to less than 50. All right. So what I would write here is 40 to less than 50. Notation-wise, it doesn't really seem very nice to write it that way, but that's an appropriate way to write it, because if I say 40 to 50, I'm including 50. Right? And there's 9 values here, by the way. If I say 40 to 49, I'm excluding all the values between 49 and 50. If I say 40 to less than 50, I'm saying getting right up to but not hitting 50. All right? In interval notation, that would be the same as writing 40, comma 50. All right? Just to avoid having to write interval notation every time, we tend to write it this way. All right, hit the right arrow. 50 to less than 60 has 25 values. $60 to less than 70 has 10 values. 70 to less than 80 has 1 value. I didn't update the data from last year, so it's missing a president, but it is what it is. So I got 4 points or 4 entries, 4 bars in my histogram, so we're good to go there. All right. For a relative frequency, so bottom line is, when I give you an assignment to create a histogram, and if it's a pencil paper situation, I might give you a whole lot of extra stuff that you don't need in terms of rows. That's fine. You don't have to use up all the rows. All right. You do have to meet the requirements of the problem. Sometimes a question will say having at least 5 bins. All right. This one didn't say any of that, so it's fine. All right. So what I would do for relative frequency is just figure out what percent of the whole each frequency value represented. All right, so each of these values, the intervals would be exactly the same. For relative frequency, we know that there's a total of 45 values. All right, so I'm just going to divide each of these entries by 45. All right, if you want, you could do it in a table. You know, just type in the numbers, just so it's, one-stop shopping. So in L3, I would just take all the entries in L2 and divide it by 45. And we get the percentages that way. 3 significance, all we need, so 0.2. 0.556. 0.222. And 0.0222. All right. We should have 100% of the values here. So if I add up these numbers, so if I take second stat math 5, which is sum of L3, I should get a 1. Now my rounded values might not be precisely equal to 1, but they should be close enough that they would round to 1. All right. for cumulative frequency. That's an accumulation of frequencies. So I have 9 entries after my first interval, after my first bin. So then what I would be doing is gaining another interval. All right. I would gain another interval along with the 40 and 50, or 40 to less than 50. All right. So these two would go together to make one mega interval. All right. So we start off at 40. We go to something less than 50, but then we pick up at 50 and go to something less than 60. So in reality, we're going from 40 to less than 60. Yeah. Oh, dang it. Thank you. I was on a roll, too, with a great explanation. Nobody could see it. Sucked. All right. Thank you, thank you. So we have 40 to less than 50, 50 to less than 60. Put them together, you're really going from 40 to less than 60. All right. If you put those two intervals together, you're going to put the frequencies associated with those two intervals together also. So that's going to get you 34 as a cumulative frequency. All right. So then if I take the next interval and plop it into the mix, we're saying that we're going from 40 to less than 50, 50 to less than 60, and then 60 to less than 70 altogether is really saying 40 to less than 70, which means that I'm taking all three of these frequency values and combining them, and that gets me to 44. All right, so just following that trend, that relationship, we know that the next one would be 40 to less than 80, and we would gain the one remaining value, bringing us up to the total number of values in the set, which would be 45. All right. So you'll see that it, for the relative frequency and cumulative frequency, it's not really calculator specific. We didn't use the calculator for anything more than simple arithmetic. All right. It would be the same idea for Desmos also. All right. So it's really that first thing, that first table, that's where all the magic happens. So then from there, we create a graph. All right. I'll just do the first one for you because I don't want to keep you too long. I'll give you some time. All right. So my intervals, my frequencies, I'll just say X and F. So along the horizontal axis, I'd put the intervals, or the intervals. All right, so 40 to less than 50. I like to do it kind of like on a diagonal. All right, so first off is that my first interval doesn't start with 0, so I put a little break mark there. And then kind of do it on a diagonal. I have 3 intervals, so it's going to be kind of squishy. So 40 to less than 50, 50 to less than 60, 60 to less than 70, 70 to less than 80. And these are my X values. I just put a nice little X there. My frequency values go as high as 25. So I can go by 5s. 5, 10. I'll only mark off every 10 though. And then just ballpark the height of the bars. All right, so the first one has a height of 9. I shorted it, dang it. $25. Gotta say, nerve damage sucks. You do see what my my shaky handwriting is capable of prior to the autocorrect, though. That's what I got to do by hand. So that's the histogram on paper, properly labeled, full credit. All right. Same idea would be in play for the relative frequency and the cumulative frequency histograms. I won't bore you with that because it's really just different labels and different scale, but it's the same general structure. All right. So I wanted to take a couple seconds and just show you how to do the histogram, or remind you how to do the histogram on Desmos. All right. When you go into Desmos, all you have to do if you have a raw list of data is just paste it in, and it'll show up as a list. But if you want it to show up as a table, so in tabular form, you can try, but it's not gonna do what you want it to do. So a nifty trick would be to create a second column and paste in both columns. You know, just some column of dummy information. All right, so, and then it'll paste it in as a table. I don't know why it won't let you just paste it in. You know, if you want one column of information as a table, or information posted is not the right word, but saved as a column within a table. It won't let you do it one column at a time. So just create a second column with like nonsense in it, and it'll let you do that. All right. So that's only if you want it to look like that. That's fine. Then type in histogram, ideally correctly, and then indicate where that information is. You'll see things like bar heights. You got the count, relative. The count is what we're looking for an ordinary frequency histogram. The relative is the relative frequency histogram. So it'll get it in percentages for you. You can center it, you know, your bins, or put it on the left. We do centered, so that's a good default. But if you click on bin width, all right, it'll bring up the true computation. All right, that Desmos used to create the graph. Change that 1 to whatever you want it to be. All right, I wanted bin widths of 10. So I'm going to zoom out from there and look at the graph, but you can see it goes pretty tall. So it's tall and kind of narrow. So what I would do is I would go into the wrench. It's not going to show up in the video, but that's all right. My x-axis, I would just change the settings on that to go from 0 to 100. And then I would also turn off this plot so it isn't as distracting. And if you're submitting this as work on an assessment, then just turn on your labels and, you know, put in X and F. It'll show up on the graph. So you got your X over there, your F over here. So that's good stuff. Now in terms of the actual heights, it's pretty easy to see what they are. You know, it's 20, 18, 19, and so on. All right. This does look a little different from what we did on the TI, because ours went with a starting value of 40 and then on from there. All right. So that's okay, as long as you know what your bins are. So here it's doing a bin width of 10, but starting at 35. All right. So you just got to be careful about that. You could also change this to left. It's just, I find that can be a little confusing for folks, but it's okay. If you put it to left, you would just have to know that this interval is really 40 to less than 50. This one is 50 to less than 60, and so on. All right, it's still doable. It's just weird, you know, because Desmos is really a function grapher, and so it also does statistical things, but it has the underlying programming related to function mathematics. All right, so it'll make the stat stuff work, but it's not going to adhere to the notation and things like that for statistics. All right, it's going to just kind of blend it, and sometimes that can be confusing. All right, so that's where I'll leave it.